Hello and welcome to Module 14, Transport Layer. All right, so don't forget to write the notes and submit them when we're all done. All right, so what is the responsibility of the transport layer? So please write the following down. The, the transport layer is responsible for the logical communications between applications running on different hosts. All right, so the transport layer has two protocols that we're going to be dealing with. We're going to look at the TCP, which stands for Transmission Control Protocol, and UDP, User Datagram Protocol. So write the following down for TCP and UDP. TCP is connection oriented, reliable with flow control. UDP, connection less, unreliable with no flow control, but it's faster than TCP. So all the applications on the top, such as FTP, HTTP, SMTP, sends their data to TCP to be transported. And DNS and TFT, for example, DNS sends it either to TCP or UDP. If DNS is outside the LAN, it sends it to TCP. If it's inside, it uses UDP. TFTP is always inside the LAN, it uses UDP. We'll explain the difference between them in a few minutes. All right, so when you create the segments over here, right here, then both of them will give that to the IP protocol, will encapsulate the segments that they create into a packet. That's what IP does. And then IP gives that to the LAN, to the NICs. And then the NICs will encapsulate the packets, the IP packets, into frames before they put them onto the wire, right? So another thing that I want you to know, this is the UDP. We'll talk about that. We'll get into that. So just as a rule of thumb, remember that TCP is typically for communication outside your LAN. UDP is for communication inside your LAN. Think of it this way. It's just like if you are going to the post office and you want to send a registered letter, you want to make sure that the letter gets there and you are notified when the letter reaches there. That's TCP. The overhead is you have to pay a little bit more. UDP, you just send the letter the least expensive way. You don't even know if it gets there or not. Something like that, right? And it's less overhead. That means you don't have to pay as much. All right, so let's take, so with TCP, you're going to establish a session. You're going to ensure that the data reaches there. You're going to make sure that everything is in order when it gets there, and you're going to control the flow of the data. All right, so write these down, the TCPIP features, okay? Establishes the sessions, ensures reliable delivery, provides same order delivery, and supports flow control. All right, here is the data from they got from the application layer, and these are all the labels that are stamped on it, and this whole thing becomes a segment. Actually, the data is broken down into little pieces, and each piece, because if the data is too big, you put all of these labels on it, then this whole thing is called a segment. So you may have a lot of segments, depending on which segment, you label them by using the sequence number. So the sequence number tells you if this is segment 1, 2, 3, 4, 5, and so on. So if the whole piece of data that came from the application layer is 5 or 10, let's say it's 10 segments, sequence number will be 1 to 10, depending on how many of the pieces. So when the guy receives it at the end, they'll be able to put the data back together, right? So this is an explanation of all the headers that are on the TCP. All right, so these are the protocols. We're going to discuss all of that. UDP is pretty much the same thing, but a lot less labels. So the less labels that are stamped on the segment, the faster it moves. All right, so, and these are the different protocols that use UDP to transport your data for quickness. And most of these, except for video, voice over IP, and video conferencing, typically are inside a LAN. All right, so there's no need to control the transmission. All right, port numbers. Port numbers are used, please write the following down. Port numbers are used to identify which application is enclosed in the segment. So that's important to know. You have a source port number and a destination port number. So what you have here is a source, and the destination port is where you're always going to be going to, and the source is the one that you make up, which we'll talk about in a few seconds. So that when the receiver sends you back the data, they're going to use the source port number to send the data back to you. All right, when you are a socket, you need to know what a socket is. A socket is always an IP address along with a port number next to it. So when you're at 192.168.10.3 and you see a colon and you see a 4-digit number, that's a socket. The port number is after the colon number, right? So the socket is an IP address combined with a port, okay? All right, so here are the 3 different types of port numbers. There are the well-known, the registered, and the private. So the well-known is from 0 to 1023. These are the most widely used port numbers that are used on the internet. So please write this down, at least the ranges. The registered are pretty much, they are controlled by IANA, and you have to pay for them. And so, for example, Cisco uses port 2000 for their phones, so no one else can use. So they are between 1024 and 49151. And then you got the private or dynamic, which means these got to be the destination port, and you just pick up one of these for your source port when you are transmitting. All right. And these are the typical port numbers that are used, the most common, well-known, let's say. All right, so most protocols will use these protocols. So if you want your firewall to block HTTP, you tell them block port 80. So any segments that has port 80 stamped on it will not be allowed to come into the network, right? All right, so that stat command is the one that allows you to see. Here's a socket. So 192.168.1.124 with port 3126, that's a socket. All right, and it's established. You need a socket to be able to get to the destination. Okay. All right, so let's talk about the TCP/IP communication. So what I want to do is I'm going to go off the slides and I'm going to go into my notes. So I want you to write everything right here in these notes. So let's take a look at the TCP/IP operation. Please write everything down. So the application protocols that use TCP/IP is SMTP, POP3, IMAP4, Telnet, SSH, HTTP, HTTPS, FTP. They all use the TCP to transport their data. Here's the first thing that happens when TCP gets the data from the network layer. When TCP receives the raw data from the application layer, it's going to take it and it's going to divide it into smaller, what we call segments, smaller pieces. And on each segment, that's number 2, is labeled with a sequence number. You know, this is number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So you number them with the sequence numbers. Number 3, after you do that, then each segment then is labeled with a port number to identify what type of data that's in there. Let's say if it was an email. So you stamp on it as a destination port, port number 25 on all 10 of them, right? And then you pick up then you go to the dynamic port and you just pick up randomly a port and you put that as the source on all of them, source port. All right, so when that's all done, the segment is done. So what TCP is going to do, because we call it a connection-oriented, he's going to make a phone call to the receiver, say, hello, are you there? The receiver sends out an acknowledgement, says, yes, I'm here. And then the sender sends out back an acknowledgement, say, I acknowledge your acknowledgement. It does a 3-way handshaking. So this is like you're making a phone call to your friend before you go to their house. Tell them, are you there? I'm coming. So you make a connection first. UDP doesn't do that, by the way. So once the connection is established, then you start sending data. We call him a reliable with flow control, and here's how that works. Once the connection is established, TCP will transmit just the first segment, the one with segment sequence number 1. And then he waits for the receiver to respond back. The receiver is going to respond back and is going to say, okay, I received your packet, and this is what it received. When you see acknowledgement number 2, that means packet that has sequence number 1 was good. It says window number 3 means this is what the receiver sends back. See, please sends me 3 segments. That's what the window size means. Starting with number 2. That means the first one with sequence number 1 was good. All right. So he's going to send them number 3. No, I'm sorry, 2, 3, and 4. Right. The ones with sequence number 2, 3, and 4. And he waits for acknowledgement. And when this, let's say this receiver sends back and he says, okay, he's going to send them acknowledgement number 5, ACK 5, and window 5. What does that mean? That means send me window 5, let's say, send me 5 segments starting with number 5. That means the first 4 were good. So what I'll do is I'll send them 5, 6, 7, 8, and 9, right? The next 5, and I'll wait for his acknowledgement. You see, we are communicating back and forth. Transmission control. We're controlling the transmission of the data. All right, so I'll wait for the receiver to respond back. Let's say number 7 was bad, right? It got corrupted. So he's going to send back, he's going to drop the window size, and he's going to say, all right, let's say number 8 was bad. So he's going to say, starting with number 8, so he'll put an acknowledgement number 8, send me 3. 3 packets started with number 8. So I'll send them 8, 9, and 10. Now I know number 10 is good, so I'll send them another FIN, F-I-N packet. Tell them if all 3, the last 3 are good, we're going to close the session. So he receives all, number 8, 9, and 10, process them, and if it's all good, they close the session. Now you see, even if number 9 was good, because number 8 is in the middle and it was bad, you start all over from number 8. And you have to resend 8 and 9 again. So that's how TCP works. Reliable means you're going to make sure all the data is received successfully, and flow control. The sender and the receivers is constantly communicating with each other, either to increasing or decreasing the window size. Flow control, right? Now that creates a lot of delay that is not acceptable when you're doing voice over IP or video streaming. All right, so that's TCP operations. So let's look at UDP. Please write the following down. UDP uses TCP among other protocols like TFTP also. TFTP, DHCP. They use UDP to transmit their data. Now, unlike TCP, UDP is connectionless. All he does is he receives the packets, breaks them up into pieces called, even, some books calls them datagrams, but I think most books now call them segments, even though UDP breaks them up into pieces. And all UDP does with the segments or datagrams is he labels the port numbers on it and he starts to transmit. It's connectionless, doesn't do the 3-way handshaking like TCP does. No reliability, no flow control, unreliable with no flow control, right? So connectionless, unreliable with flow control, but it's fasting. So it does it, but much faster than TCP. So this is more appropriate for what voice over IP likes to use, because it's fast. There's no delay like TCP. But the problem with UDP doesn't do sequence numbers either. So, but you need that for voice over IP in case a packet gets lost. So we improvise UDP just before we give for voice packets and video streaming. Before we give the data to UDP to transport the data, we use something called RTP, real-time protocol, and RTCP. We use both of these to simulate TCP for video, voice over IP, and video streaming. All right, but more of that will be discussed in other classes later on. All right, so that's it for now. Hopefully you'll understand the difference between TCP and UDP. Both of those will give these segments to the IP protocol in the network layer to encapsulate those segments into packets and move on from there. All right, so write everything that I told you to write on the transport layer, and when you are done, submit that as homework, and I will see you in chapter 15. All right, we're moving right along.